Hey friends, in this short video we'll learn about arithmetic series. So what is an arithmetic series? Consider this, for example, we have 1, 2, 3, 4, and it goes on. So we see that here the successive terms differ by a common difference. Here the common difference is 1. Okay, 1 and 2 differ by 1. 2 and 3 differ by 1, 3 and 4 also differ by 1. So any series in which the successive terms have a common difference is called as arithmetic series. Other example can be, suppose you have 6, 8, 10, 12, 14 and so on. This is also an arithmetic series, and here the common difference is 2. Okay, the successive terms differ by a common difference, and here it is 2. Other examples of arithmetic series can be this. For example, consider you have -8, -9, -10, -11 and so on. Here the common difference is -1. You can also have a series like 6.5. Can have 6, 5.5, 5, 4.5 and so on. Here the common difference is, what do you think? The common difference would be the difference between the second and the first term, or the third and the second term. Here the common difference would be -0.5. Okay, so all these are examples of arithmetic series. Now, how do we generalize an arithmetic series? We can write an arithmetic series as, the first term can be written as, we generally call it, so the first term can be written as A1, second term A2, third term A3, and it goes on. Suppose you have n terms in an arithmetic series. The nth term here would be an. Now, as I told that in an arithmetic series, the successive terms differ by a common difference. So here, if A1 is the first term, A2 is the second term, and A2 is nothing but A1 plus D. Here D is the common difference. Okay, so D is the common difference. Similarly, A3 would be the third term, and this would be A2 plus D, and A2 in turn is A1 plus D. So A3 will be A1 plus 2D. Similarly, A4 would be A3 plus D, and if you just simplify it, it would be A1 plus 3D. So you see a pattern here. A1 is the first term, A2 is A1 plus D, A3 is A1 plus 2D, A4 is A1 plus 3D. So similarly, the last term, the nth term, would be an equals A1 plus, it would be n minus 1D. Okay, so this is the first term, this is the nth term, or in this case this is the last term. Now we'll derive the formula for the summation of an arithmetic series. Okay, now let the series be, in fact, let the sum be S. S is A1 plus A2 plus A3 plus, let the last term be An. So this An would be the last term. Now A1 is the first term, A2, as we have shown here, is nothing but a1 plus d. Okay, a3 is nothing but a1 plus 2d. Similarly, a4 here would be nothing but a1 plus 3d. Now the nth term would be nothing but a1 plus n minus 1d. Okay. Now if you observe here carefully, we can add all the a1s here. Okay. Now how many times do we have a1 here? You can look at it in this way. We have a1 here, and then we have a1 repeated here. This is a1 one time, a1, this is the a1 repeated second time, this is the a1 repeated third time, and this is the a1 repeated for the n minus 1th time. So this can be written as n minus 1 times of a1. Now we will add all the d's, that is the common difference. Okay, this would be d plus 2d plus 3d plus 4d. This will go on till n minus 1d. Sorry for the background noise. Now this can be written as a1 plus n minus 1 a1 would be nothing but n times a1. Okay, now what we can do here is we can take d common. D is common, then we'll have 1 plus 2 plus 3 plus 4 till n minus 1. Okay, then we have n times a1 plus d. Now we know that this is a sequence of n natural numbers. Okay, now we know the formula for summation of n natural numbers, and that is summation of, suppose you have summation of n natural numbers can be written as n plus 1 by 2. Okay, now in this case our capital N is nothing but n minus 1. So we can write it as, so suppose if n minus 1 is n here, okay, so n plus 1 by 2 would be the sum of this sequence, and this can be written as, so let us write it down here. Okay, here n is n minus 1, so n minus 1. Now here capital N plus 1 would be nothing but small n minus 1 plus 1, which would be n upon 2. Okay, now yes, now this can be written as n times a1 plus n by 2 n minus 1 d. Now we can take n, okay, common from this. So n can be taken out, and this can be written as a1 plus n minus 1 d by 2. We can multiply this 2 here. We have n by 2. This would be 2a1 plus n minus 1 d. this can be further simplified as n by 2 a1 plus n minus 1 d. This can be also written as a1 plus, now what is a1 plus n minus 1d? We have shown that a1 plus n minus 1d is nothing but the nth term, that is the last term. This would be an. Okay, so we have derived the formula. The sum would be equal to n by 2 times a1 plus an, where n is the number of terms in the sequence, a1 is the first term, and an is the last term. Thanks for watching.